Okay, so we're looking at function tables. Here's a function 2x plus 5. This is just like when you had input-output tables. The rules are just more complicated. So this rule is basically saying multiply by 2 and add 5. We're not going to write this out on each one, but I thought that I would point it out on this first one. And instead of writing input, output, we're going to write x and f of x, which actually equals y. F of x and all of the other function notations that you've seen with different letters is just really a fancy way of saying y. It's a way that you can do y where you show the inputs and you can name a bunch of different functions, f, g, h. So anyway, so really if I have numbers over here, this side is the input, and this side is the output. What they're doing is just giving you some new notation, and we're capable of making the rules more complicated than what you would have done earlier on. Because you start doing input-output tables like, I don't know, 4th, 5th grade, maybe even earlier than that, looking for rules and things like that. So most of the time, you're going to have some numbers that just go in order. So I'm going to do -2, -1, 0, 1, and 2 for my inputs. These are my x values, so just to review, remember that this is now my domain. And normally when you are asked to do these, they're going to give you these numbers a lot of times, and then you're going to fill out this side, at least with 8th grade, you're going to fill out this side. So my rule is 2x plus 5, but that just means you're going to take your x number, multiply it by 2, and add 5. That's how we're going to get the output. So over here, I'll just write my work to the side and then I'll put the answer in the table. I'm going to take 2 times -2 plus 5. So I'm just taking this input and putting it in where that x is. So what's 2 times -2? Yes, Brian?
-4.
Good. And then if I add 5 to it, -4 plus 5, what would I get? Go ahead, Brian. You can finish that one.
+1.
Good. So that's what's going to go in over here. And what this is this is a point. It's -2, +1. I could put that on a graph, which we'll look at in the next lesson. Okay, then I just go down the line to the next one, -1. I'm going to add 5. So now I have 2 times -1. So what would that be? 2 times -1. Brian, you did 1, so let's have somebody else. Rhett, why don't you do this one? 2 times -1 is -2, and then what's -2 plus 5? +3, thank you. And so then this is 3. So now I have the point -1, 3, input, output. Jaden, you're going to help me on the next one. So the next one I have 0. I'm just going to put 0 in. So what's 2 times 0?
0.
Plus 5? 5. I like 0, because usually when you put 0 in, the math's pretty easy. And then Johnny, you're going to help me with the next one.
It's 7.
Okay, he's already done it. So 2 times 1 is 2, plus 5 is 7. So he was working ahead. Good. And then did anybody have this last one? Are you guys working ahead? 9. So 2 times 2 plus 5 would be 4 plus 5, which is 9. And so these are my points. So this is my domain. That's my inputs. What I got out of it is my range, which is my outputs. And I want to point out a couple of things to you guys that we've talked about in the past. But when you do this, it suddenly becomes super clear why you call things what they are. When I have the expression, hang on, I'm having lead issues today. If I have the expression 2x plus 5, we talked in the past about what things were called. This is a term. This is also a term. So we have 2 terms. The numbers 2 and 5 are called constants. So 2 is a constant. That's because it's just a number. 2 doesn't change in value. And 5 is a constant. It doesn't change in value. And if you look at all of these calculations we did, the 2 and the 5 are constant. They're the same thing all the way down. But the numbers that we put in for x, they change every time. What do we normally call things like x when they're in algebraic expressions? Variables. We call them variables because when we work with them, the number that goes in for x is going to vary. It's going to change. So this is where I think the idea of a variable becomes real, because that number is changing every time. It varies. Does that make sense? Yes. Yeah. So I just wanted to point that out. That's just a little blast from the past, all of these names for things. But it really makes sense when we do these repeated calculations. You might also notice that the changes in the y values were pretty much the same every time. This went up 2, this went up 2, this went up 2, this went up 2. That's because we were multiplying by 2. But they're not even numbers 2, 4, 6, 8 because we also added 5, which changed it a little bit. Okay, so I'm going to talk about a couple of other kinds of functions. Let's go down and do another one. Let's say I have, so we did f of x. I'm going to name this one something different just so we remember it's different. I'm going to have g of x equals, say, negative x plus 7. So write that down. That's basically my function rule. They actually call it that, function rule. And we'll just go ahead underneath that and make our table x and f of x. And we'll just do 4 numbers this time to save a little bit of room. And I am going to put in some negatives. So negative 2, negative 1, 0, positive 1. So what we're doing is we're evaluating this function for all of these numbers, just like we did when we learned how to evaluate functions. We reviewed that this morning. But we are doing it multiple times with different inputs. So on this one, I have negative x plus 7. So when I have negative 2, I'm going to have negative from here, and I have the negative for the 2, and then I'm adding 7. So that's a little confusing, and some of us have struggled with that. If there's a negative here, and I'm putting a negative number in, and I get a double negative, what does that do?
Makes it positive.
It makes it positive. This is the same thing as positive 2 plus 7. So if I have 2 plus 7, I get 9. And the same thing will happen if I put in negative 1. Negative 1, negative negative 1 is the same thing as just 1. And when I add 7 to it, I get 8. So just don't forget, if you have a negative in the problem and then you're putting another negative in, and it looks like this with the double negative, it will cancel and become positive. All right, so negative 0 is not super meaningful. It's just 0. And if I take 0 plus 7, we just get 7. So this would just be 0 plus 7, and we get 7. I guess I could write these over here and in the table. I wasn't doing that. And then for the next one, we'll put in 1. So I'll have negative and then 1. So this is just negative 1 plus 7, which is 6. Okay, so makes sense so far? I'm just going to do one more, and I'm going to show you, sometimes they'll do a horizontal table, so it's not like it's complicated, but I want to make sure that we have an example. So let's do a of x. So the cool thing about not calling all of these y is I get to give them all different names. So if you had a problem with multiple equations, you can give them all different names. And let's say that this one is, let's do 8 minus 3x. And then we're going to do a horizontal table this way. So I'm going to put x here, f of x here, and draw my line like this.
Oh, so it just doesn't change anything?
It doesn't change anything. It's just putting the table sideways. And you will see these done both ways, like all the way through high school. So I'm just sort of introducing it so it doesn't throw you off. Sometimes if they change the way it looks, our brains panic. I just want to make sure that we're okay. So let's do 5 numbers. We'll do -2, -1, 0, 1, and 2. It can be any numbers. They don't have to go in order, but a lot of times they will, especially when we're graphing next week. So I just wanted to point that out. All right, so I don't have the same space next to these to do all the work, so I'm just going to write the work out down here. First number to put in is -2. So I'm going to have 8 minus 3 times -2. So what happens if I have this minus, or this minus and this negative sign?
You do the multiplication first.
You do the multiplication first. So if we're just strictly doing order of operations, I would take 3 times -2, which is -6, right? And then I still have 8 minus -6. And I still have this double negative. So what's going to happen to that?
Keep, change, change.
Keep, change, change. And it's going to become 8 plus 6. It's going to be positive. When we get into high school, a lot of times I'm going to jump from this to this because I think of this as -3 times -2. And I probably shouldn't do that, but I'll just warn you that sometimes I end up skipping a step down to here. But you can still think of it that way. And so we would get 14 for that first y value. And f of x is just the y. And then -2 would be my input, so 8 minus 3, I'm sorry, -1. And so if you were using my little trick, I would just go, okay, -3 times -1 is +3. I'd make that +3. I just kind of shortcut it. If you don't like that, you can still do it how we did over here. And then the next one should be super easy because I'm taking 3 times 0.
It's 3.
So it's 8 minus 0. A lot of people do like mess up and will say 3 if they're hurrying. But you should just get 8. And then I'm going to put in 1. And then once you get to the positive numbers, it's easy because this is just going to be 8 minus 3. And you get 5. And has anybody done the last one? I know sometimes you guys
2.
work ahead. It's 2.
Because the solution is just -3.
Okay, so I'll write it out. 8 minus 3 times 2. So it'd be 8 minus 6, which is 2. Good. So remember that these are just y values. All of this is your range. It's your outputs. Do you notice any patterns for the f of x part of the table? What's the pattern?
The pattern is -3.
Yeah, it's going down 3 every time. So if we look at our equation, that makes sense. Because we're taking x times 3 and we're subtracting it from that starting number. Okay, so this is what you guys are going to do on today's assignment. And my hair is everywhere, sorry. And I'm going to stop this.